Excessive consumption of fossil energy causes environmental problems such as increasing air pollution and greenhouse gas effect. Pollution due to the use of fossil energy can cause health problems such as breathing problems. Meanwhile, the world energy needs continue to increase as the population increases. So, we need environmentally friendly energy storage technology with high density. Therefore, we, Delegate Diponegoro University, thought the present motivation in the form of utilizing used heroes for nanocomposite lithium ferrophosphate as component of high lithium batteries.
As for the results of the research to be conducted, some of the material obtained include lithium iron phosphate powder and carbon powder. It can be seen in the picture that the lithium iron phosphate and carbon materials have the same color, namely dark black. Lithium iron phosphate C fabrication result. In the synthesis of C-doped lithium iron phosphate, the variation in composition is 0.25 grams, 0.5 grams, 0.75 grams produces powder material with the same color as the base material, namely jet black. In plain view and based on measurement result, the third variation of synthesis has no color differences and the resulting weight is the same. So the result of the characterization test that we carried out are XRD test. Based on the analysis result, it can be seen that the particle structure of variation 1 is amorphous due to the addition of more carbon. Then in variations 2 and 3, the particle structure is crystalline as evidenced by the sharp peak in XRD result. Based on the XRD result, it shows that C-doped lithium iron phosphate was successfully synthesized. SEM test, based on the analysis of the material surface morphology of the three variations of lithium iron phosphate C25, lithium iron phosphate C50, and lithium iron phosphate C75, it can be seen that the lithium iron phosphate C25 material has almost uniform properties. The morphology is round and in some parts the material can be seen fused, whereas for the lithium iron phosphate C50 and lithium iron phosphate C75 materials, the uniformity of the shape is decreasing and a lot of material is fused inside it. From the test result, it can be seen that the sizes of variation 1, variation 2, and variation 3 are 4.1 μm, 7.12 μm, and 9.65 μm respectively. Al-Karbaki et al. 2020. CV test. The CV characterizations result for all composition variations have good oxidation and reduction properties seen from the continuous curve. The composition, lithium iron phosphate C25, has a capacitance of lithium iron phosphate 15.845 picograms, lithium iron phosphate C50 of 21.56 picograms, and lithium iron phosphate C75 of 7.65 picograms, which means the composition is lithium iron phosphate C50 has a capacitance of 15.845 picograms. Highest capacitance, the capacitance value in the third variation is much greater than the capacitance of lithium iron phosphate without the addition of carbon, namely 1.095 picograms. The IS test can be seen from getting the Rs and Rct values for the third variation shows that the variation 1 gets an Rs value of around 2500 ohms and Rct 200 ohms. For variation 2, it gets an Rs value of around 2000 ohms and Rct 150 ohms. And variation 3 gets no result. The data is in accordance with the capacitance result, namely the largest capacitance is the lithium iron phosphate C50 material or variation 2.
Utilizing used biowaste as a lithium battery component is an innovation that can make a positive contribution to achieving the 7 point of the Sustainable Development Goals or SDGs, namely affordable and clean energy. By integrating used biowaste as a lithium battery production, it not only reduces the amount of waste that pollutes of the environment, but also increases the energy resource that can be accessed by society. Used biowaste has great potential as a lithium battery component which can provide additional economic value for used tires that are not on use. The recycling process not only helps reduce environmental waste, but also creates new opportunities to optimize research and increase economic sustainability. The initiative creates sustainable solutions that support global effort to increase accessibility to environmentally friendly energy, in line with the commitment to achieving the SDGs. Research on lithium-ion battery technology needs to be developed because energy needs the world are increasing and the problem of used tire waste be addressed immediately.